Hi everyone, it's Mrs. Summer here to talk about lesson 603 part 2. So in the 603.1, you just did stoichiometry. It was with cookies and batches, but that is the heart of what stoichiometry is. So now let's apply it to chemical equations. So remember coefficients? Coefficients, when balancing chemical equations, we say that coefficients show us the number of molecules needed for a reaction. However, we cannot just have 3 O2 molecules in one container, because if you recall from previous lessons, there are 6.022 times 10 to the 23rd molecules in 1 mole of something. They're just too small to have just 3 molecules of O2. So instead, the coefficients represent the number of moles of that molecule. Okay? In this chemical equation, iron and oxygen reacting to form iron 3 oxide, we have 3 moles of O2 because that is the coefficient here of oxygen. We have 4 moles of iron because in the balanced equation, 4 is the coefficient. And we have 2 moles of iron 2 oxide. So we use that in this reaction. So just like in the cookie example where we made a mole-to-mole ratio, because we said that 4 moles of eggs equals 1 mole of batches of cookies, or we could write it as 1 batch of cookies is equal to 4 eggs over 4 eggs, depending on what we need to use it for. We can also make a mole-to-mole ratio between the amounts of moles in any 2 compounds involved in a chemical reaction. So for example, 3O2 plus 4Fe, we have in this ratio, or yields 2Fe2O3. Sorry, this should write over here, 2Fe2O3. We can write the ratio as 3 moles of O2 over 4 moles of Fe. We could write 3 moles of O2 over 2 moles of Fe2O3. We could also write it as 2 moles Fe2O3 over 4 moles Fe. You can write any ratios between the two using the coefficients of the balanced chemical equation. So let's try making this mole-to-mole ratio. The coefficients from the balanced chemical equation of 2H2 plus O2 yields 2H2O. Write the mole-to-mole ratio for H2O to H2. So what I'm going to do is I'm going to look at my coefficients. So my coefficient for mole ratio for H2 to H2 or H2O to H2. So I have 2 mole H2O to 2 mole H2. It's really important that you write the 2 mole and not just 2 H2O or 2 H2. Okay? Or we could write 2 mole H2 over 2 mole H2O. Mole-to-mole ratios is how we can convert between one substance and another in a chemical reaction. It's a conversion factor. So for converting between one substance and another substance, you need to use the mole-to-mole ratio as your conversion factor. In your notes or in the map, you should fill in this information. It's in the course information section of Google Classroom. You can print it or use Kami. In person, you will receive a paper copy, except for none of us here are in person. That note was for Ms. Fleischer's class. So stoichiometry in this section is the relationship between the amounts of substances in a chemical reaction, is using conversion factors to solve problems. Okay? Then on your map, you should be writing mole-to-mole ratio between substance 1 and substance 2. So in order to get from this substance 1 to amounts of substance 2, you need to use the mole-to-mole ratio. Okay? You can't go from grams of one substance to grams of another without going through the mole-to-mole ratio. And the mole-to-mole ratio is used as a conversion factor to convert between 2 substances. It's the coefficients of the balanced chemical equation is the conversion factor. So steps to solving stoichiometry problems. Write your balanced equation. Set up your work following the units. Identify useful conversions. Do the math, and then write your answer with the correct units. So here's a question. It says, how many moles of oxygen are produced by the decomposition of 6 moles of potassium chlorate? So step 1 is write your balanced equation, and it appears that this equation is already balanced. Then it wants to know, then set up your work following the units. So we are given moles of potassium chlorate. So we are given 6 moles KClO3, which means on the bottom, my moles of KClO3 must be on the bottom of my conversion factor. And because I want how many moles of O2, I want moles of O2 on the top. So what is my conversion factor between KClO3 and O2? Well, the coefficient for KClO3 is 2, and the coefficient for my oxygen in this reaction is 3. So then I've set up my useful conversions. Now I got to do the math. So 6 times 3 is 18. Divided by 2 is 9. And then write the answer with correct units. So 9 moles of O2 are produced by the decomposition of 6 moles of potassium chlorate. So you try. How many moles of iron will be needed to make 8 moles of iron 3 oxide? Remember to write your balanced equation, set up your work and follow the units, identify useful conversions, do the math, and write the answer with the correct units. So to solve this, I set up my problem. I have my 8 moles, because I have what it's given, of iron 3 oxide. And then my conversion factor, since I have iron 3 oxide is what I'm given, iron 3 oxide needs to be on the bottom. And so my 2, because that's where the coefficient of iron 3 oxide in this equation is. And then I want iron, so 4 moles of iron goes on top. Then I do 8 times 4, 32, divided by 2 is equal to 16 moles, and I forgot 16 moles of Fe. Okay.